Again, welcome everyone to the IMAGIN Webinar Series number 6. Today we'll be having a presentation on processing building plans using FME Server with Brooks Kelley from Avinion. I'm Jerry Swanson. I'm on the board of directors for IMAGIN. And just have a couple slides to go through before we hand it over to Brooks. So I'd like to give a shout out to our sponsors for the webinar series, Fishbeck as well as Giffords Webster. Appreciate the support, and definitely good to have them along as a sponsor. So we also have some upcoming webinars. All of our webinars are from 11 to 12 on a Thursday. We're usually doing them every other week. And so there'll be the next one actually next week because we made some rearrangements with the state meeting last week. So next week we will have Brownfields to Brightfields, Recycling Land to Productive Use by Ryan McNeil at the State Land Bank Authority. And then on March 4th, we will be having Pete Schneider present Geodatabase Replication, Distributed or Disturbed. So look out for those. There'll be some invites coming out to register. And then as the presentation goes on, there's a question box on your GoToWebinar pop-up. So feel free to send questions through, and Brooks is also open to taking questions as they come in. So I'll be keeping an eye on that, and we can tackle them as they come. Or at the end, we'll also go through all the questions remaining and have a little Q&A. The webinar is also being recorded, so we've been recording and putting these up on our website, usually within a week of them being completed, so look out for that. And as always, check out imagin.org for more information on the webinar series. So with that, I'm going to go ahead and hand it over to Brooks.
Okay. Well, thanks for attending, everyone. I'm looking forward to sharing this project with you, and appreciate you guys taking an hour out of your day to hear me out. Also, thanks to IMAGIN for putting this together. It's been kind of a rough year, and we didn't get to have our conference, and there aren't any meetups or anything like that, and the contact between us is not as much as it should be. So this is a nice forum to be able to discuss some exciting things that we're all working on right now. So this is a neat little project I've been involved in over the past year, involving the use of FME and FME to process building plans. This isn't really a GIS presentation per se. Mostly what I'm going to be talking about here is AutoCAD drawings. But I thought this might be useful to IMAGIN members, especially those of you that are in local government and utilities, because I know you guys deal a lot with AutoCAD drawings, or CAD drawings, I should say, to either standardize those into a format specific to your organization, or to bring them into GIS. And some of the tools and techniques that I'm using here might be applicable to you, what your guys are doing. So a little bit about the company I work for, called Avinion. Yeah, we're a global company. We're focused on IT, geospatial, and engineering. We kind of have two halves here, data services and consulting. That's kind of where I work. We've been around for over 25 years. We have a real strong federal presence. Our headquarters is right outside Washington, D.C. in Northern Virginia. We're big in geospatial, as many of you know. In fact, my boss's boss used to be the head of the Esri DC office, which is one of the busiest ones they have. And for any of you GISPs out there, my immediate supervisor, Martin Roche, is the guy that signed your certificate. So we're pretty deeply involved with the industry. We also work with a lot of great business partners like Esri and Oracle, and myself and several others do a lot of work with FME software, which we're going to talk about today. So we're global in presence. We work for large organizations such as the federal government, McDonald's, PG&E, and Southern Company. We're big in Europe, especially the Low Countries in France. It seems like every other month we're opening a new office in the Netherlands. A lot of people over there. Most of our employees are actually over in India. We have a couple offices over there, and we have a lot of talented staff over there. And we have scattered throughout the globe. We have lots of 1- and 2-person offices. For example, we have one up on the oil patch in Alberta and another in Chico, California. So having dispensed with the corporate stuff, let's jump right in and talk about this project. This project was for a large federal government agency, so large in fact that it's actually the 3rd branch of government. It's national in scope, so we're dealing with offices and buildings throughout the United States and its territories. We're talking about 800 facilities with more than 500 floors. So that's almost 4 square kilometers of rentable space. So a lot of building plans to deal with here. They maintain their data in AutoCAD format, DWG, and they archive it and analyze it within IBM's Tririga system, which if you haven't heard of that, that's an integrated workplace management system. A lot of people use it if they have like office campuses and stuff like that, just to manage spaces. So things with the federal government are a little different, and I haven't done much federal government work. This was really my first big federal project. But if you guys know anything about the federal government, one thing that's pretty interesting about it is one agency owns the buildings and other agencies use the buildings. For example, if you work for the Forest Service and you go to your office, the building is owned by GSA, that big monstrous government agency, and then that space is then leased or rented to the Forest Service, and pretty much all government buildings are done in this way, which makes for kind of an interesting situation in that the owners of the building and the users of the building have very different priorities. GSA is concerned with maximizing taxpayer value, trying to get the most space for their buck, the lowest cost, adherence to broad federal guidelines, ADA and stuff like that. Whereas the owner of the building is concerned with their mission. And that varies from agency to agency, whether it's the Forest Service, a Department of Agriculture, Department of Interior, et cetera, et cetera. So they view things very differently. GSA actually produces its own AutoCAD drawings for every government-owned facility that the United States has. And these are distributed to various agencies. The agency I was working for, they have a different standard of AutoCAD drawings. Essentially, what they want is they want 2 floor-specific drawings. for every building. So if you have a building that's 10 floors and you have 2 drawings per floor, you're talking 20 drawings to model that space. The 2 standards they have are what they call the P-line drawing and the arch drawing. And the P-line drawing is very simple. It just consists of 4 different layers: gross layer, gross measured, space, and labels. Gross is essentially the building footprint, the exterior outline of the building. Gross measured is basically the interior wall of the inside of the exterior wall. So the maximum usable inside space within the building. A space is basically their term for a room, lobby, et cetera, et cetera. And then a label, all the spaces are labeled with a so-called space ID, which you can think of just as a room number. They're hierarchical, so it's like a building number plus the room number. And then all the other things, sinks, toilets, doors, furniture, windows, all those architectural details essentially go into a second drawing called the arch drawing that is then XREF'd into the first as background. Okay. And what they're interested in as they get this data from GSA, they get it every year, and they're really concerned with have things changed. So for example, has this office out in South Dakota, have they bashed down a wall and merged 2 offices together? Or have they put up a security wall and door in the lobby? And if nothing's changed, there's nothing really they need to do. If things have changed, then certain actions need to be done, and the data needs to find its way into their TRIRIGA database. So how they were doing stuff before this project was essentially a team of CAD techs. They would get this data from multiple GSA regional offices. I think there are 13. And they'd manually convert it into their specification. So kind of a sweatshop approach to this. Obviously, there are issues with standardization and consistency, and you get interrupted. These are people doing work. They're all very talented and very good CAD techs, but they're human beings at the same time. So they wanted to take what was largely a heavily manual process and automate it using FME. So here's an example. In the upper left here, you see a building consisting of 10 floors. This one's actually the Federal Center in downtown Chicago near the Jackson station. If any of you are fans of modern architecture, this is a building designed by Mies van der Rohe, and it has a big red Alexander Calder sculpture in front of it. So it's kind of a neat building. But these 10 floors here within this office building are used by this client. You can see the GSA has produced 1 drawing in their specification for the region that contains Chicago. All 10 floors are in 1 drawing, and what the client wants is essentially they want 2 drawings per floor. So instead of 1 drawing with 10 floors, they want 20 drawings with 2 drawings per floor. And that's what you see an example of one of those in the lower right. Essentially, the colorful stuff here is the arch drawing, and everything in gray is the background XREF arch drawing. So this is an example of their workflow. They want to take the GSA supplied information and they want to standardize it into their specification, and they want to do it automatically. And this is why I thought this presentation might be interesting to IMAGIN members, especially those of you in local government and utilities. I know you guys get a lot of like site plans and building plans and plans for new parks and road construction, all this sort of stuff. And you want to standardize it into a specification you can use, either an internal AutoCAD specification or bringing it into your GIS. So that's why I wanted to show this to you guys. Okay. So why did they select FME? Well, I don't know about you, but if I have to do the same thing, same conversion more than twice, I tend to automate it. And I usually automate it with FME. So, you know, the heart of this, it's ETL. It's taking something and running it through a transformation and loading it into a new database. And they needed to run this again and again, over and over again. Remember this, 5,000 floors, 4 square kilometers of office space. So they need to do this again and again. So they want the ability to batch it. Okay. Now it was interesting, when we got the RFP from the federal government for this, they knew they wanted FME. And it was written right there in the RFP. But they didn't know they needed FME Server. And again, 800 facilities with 5,000 floors every year. This data was coming in. And it was coming in on different schedules. So one GSA region would deliver the data 1 week, and then maybe 2 more the next week, and then a couple more the following month. So the data delivery was very bursty. They'd go from having nothing to having lots of data that they needed to deal with. They wanted several people to be able to do this at once, and they wanted to be able to batch it, essentially just turn FME loose on it. The final thing that they wanted was just kind of version control. They recognized that over time they'd be changing their FME workspace as they noticed new and different things with their drawings coming from GSA. And they just wanted the ability to manage those changes made to their workspaces. I know a lot of people probably listening to this call have played around with FME, and maybe not so many of you have played around with FME Server. FME Server is really a neat product, and it's kind of akin to ArcGIS Server / portal / whatever Esri's calling it nowadays, in that you use a desktop product, you know, ArcGIS Desktop or ArcGIS Pro, to author a map, and then you publish that map to ArcGIS Server or Portal or ArcGIS Online. So you have a client desktop side application and a server side application. It's the same with FME Server. You author all of your workspaces using FME Desktop, and then you publish or load those into FME Server, which then manages them in a variety of ways. For example, you can have an FME workspace loaded into Server and schedule it to run at 2 a.m. every morning. But what's really exciting about FME Server, especially with regard to this project, was their functionality called automations. And what an automation allows you to do is it allows you to wire up a triggering event to an FME workspace. That could be something on a schedule, so run at 2 a.m., run every 10 minutes, run every 3 days, some kind of a time-based trigger. Or you could have it watch an email server, and when an email comes in, do something. In this particular case, what they want to do is this whole thing is triggered by watching a folder, and it's actually a file share. So the workflow for the end user is they get a bunch of AutoCAD drawings from GSA. They dump them into a file share that just appears as a folder within Windows Explorer. They drop the files in there, and what's going on is FME Server is watching that folder and checking it every 30 seconds. So it looks at that folder, there's nothing in there, it waits 30 seconds, and during that time, somebody dumps 50 AutoCAD drawings in there. It then looks again, 30 seconds later, it says, aha, there's new data there, there's new files there, I need to do something. And what it's gonna do is it's gonna run it through a filter, because it's only concerned with AutoCAD files. So it's not concerned if you dump a new metadata file or in XML format or a README file that's in ASCII text format or something like that. It's only concerned with AutoCAD drawings. So you get 50 drawings and some miscellaneous other files from GSA. You dump them in a folder. FME Server picks up on that. It says, aha, I see 60 files here. 50 of those are AutoCAD drawings. And I'm going to send those 50 drawings to this FME workspace right here. Okay. So the workspace is fairly complex, but what FME Server is doing to control it is pretty straightforward. Okay. So here's the overall workflow. Is the user is dumping AutoCAD drawings into a folder. FME Server is watching that folder. As soon as it sees new AutoCAD drawings, it's going to send those along to an FME workspace. It's one workspace right now. And what that FME workspace is going to do is it's going to take those drawings, it's going to standardize them into the P-line and arch specifications. So you're going to start with one drawing and you're going to end up with 2 or more, depending on the number of floors in the drawings. It's then going to subject those to some QC to make sure, for example, every space has a label, that spaces don't overlap one another, all those kind of topological things that us GIS people think about. And it's then going to compare these now standardized and QC'd building plans to the existing plans within the TRIRIGA database. And if they're different, and they determine difference basically if the area of a room has changed. So if it's gone from 1,200 square feet to 1,500 square feet, it's judged to be a change. And then it's going to route that drawing accordingly. So if it has passed it's been standardized and it passes QC and it's judged to be different than the existing data within the TRIRIGA database, it's going to dump the output, the standardized drawings, into the to be loaded folder. If the drawings are standardized and they fail QC and they're different than the existing previous year's drawings, they're going to be dumped into a to be fixed folder. The idea here is they want to get the CAD techs to give that human touch to this. So if the data is ready to be loaded, they want somebody to review it prior to loading it, and then they can just load it very quickly right from within AutoCAD using CAD Integrator. If it has failed QC, a CSV format file with the specific errors encountered will be output along with the standardized drawings into this to be fixed folder. The third path is essentially that the now standardized drawings have passed QC and they're identical to the previous year's drawings. So essentially nothing needs to be done at that point. There's no further action required. The drawings don't need to be fixed and they don't need to be loaded into the TRIRIGA database. Okay. When this was developed, the decision was made to develop it as one large workspace with lots of custom transformers. And I don't know if any of the FME users on this call have ever played with custom transformers, but they're pretty cool. They're shown in green on the image you're looking at right now. And they're essentially just different tabs up here at the top. So essentially it's like a second workspace within your workspace that you can just treat as a transformer. So actually I'll just show you one. Let's see if I can do this. I had it open right there. So here's the FME workspace, and you can see that I'm calling a custom transformer called QCer. Yep, sorry, I hopped over that again. Let's go back. So you can see it's just a little separate workspace that I'm running. I'm submitting it to a bunch of QC rules, but I can just call that as if it's a regular out-of-the-box transformer. Looking back now, there's always wisdom that you gain through any project, and if you were to do it again, you'd always invariably do it at least a little bit differently. And looking back now, I probably lean away from using custom transformers so much and look at developing different autonomous workspaces that are called from one another within FME Server, kind of taking a microservices architecture approach to this. But it works fine, and that's just hindsight. You always do things a little different. Here's a list of the custom transformers that were developed. The main one is the main workspace you were just looking at. Then I have one that creates the P-line drawing, one that creates the arch drawing, a custom transformer that does the QC, one that manages the error messages, one that produces the log. Essentially, we produce a 24-hour log every day. It's a date-stamped text file that tells precisely what this did so they can review how they're doing. One that does the validation, essentially checking for the differences between the new drawing and the previous drawing, and one that calculates the area of each space and does that comparison there. Okay, so let's talk about the output. The first output are the standardized drawings. So in the example we were talking about earlier in the Federal Center down in the Loop in Chicago, we had a drawing supplied from GSA that had all 10 floors within one drawing. That's going to come out as 20 different drawings with 2 per floor. The first being the arch drawing, and the second being the P-line drawing, or first being the P-line drawing, the second being the arch drawing. Sorry about that. Here you can see the colorful one is the arch drawing. It contains the gross line, the gross measured line, the space lines in yellow, and the labels in green text. And then everything in gray is that arch drawing, kind of the background information, such as the X's here for voids, the doors, sinks and toilets in the bathroom, office furniture, windows, stuff like that, just to give it that visual context. Okay. The second thing that comes out is an error report. So there are two categories of errors, warnings and errors. Warnings are just kind of an FYI. So for example, you know, we have space at this location that doesn't have a space ID, so it doesn't have a label. That could be because it's just occupied by a different government agency or something like that. So it's one of these things that, like, hey, this isn't severe enough to stop things, but you should be aware of it. Whereas an error would be something more severe, usually a topological sort of error, such as a space cannot cross outside the gross measured line. If it fails QC, this error report in CSV format just is just a sidecar to the output AutoCAD and P-line drawings. It has the same name. For example, here's the 13th floor of that building in Chicago from this date, and it's the error report on the P-line drawing, CSV. Also, every day from midnight to midnight, we're creating a log file which allows users to track how things are going. So essentially, it just lists what's occurring as all these drawings are dropped into the input folder. So as soon as FME picks up on these, it starts writing a log. So here's a log entry for the 11th floor of that same building. So you can see that, you know, on the 1st of November at 10 in the morning, 10:06, I should say, it was ingested. 5 seconds later, it had standardized the drawing to the P-line drawing. You know, 2 seconds after that, it created the arch drawing. 3 seconds later, it passed QC. 5 seconds after that, it passed the arch drawings passed QC. 5 seconds after that, it was validated against the previous year's drawing and judged to be different. And then it just tells you that both of those drawings were output to the to be loaded folder. And that the process is complete. And then it would move on to the next drawing that was dumped in there. And these would just be appended line by line, message by message to that log file. And you get to the 2nd of November, and there'd be a new log file. So as soon as you get to midnight, it creates a new log file there. So just a way for them to keep track of what they're doing. Okay. A summary of this guy here. So remember, first off, FME and FME Server have been great for this project. It's one of these projects that, like, when I read the RFP, I was like, I know exactly how we're going to do that. They haven't mentioned FME Server, but this is the perfect use case for it. Remember the scope and the scale of the data we're dealing here with. We're dealing with facilities across the United States and all of its dependencies. So over 800 facilities, 5,000 floors every year, lots and lots of data. Also, the introduction of automations with FME Server, I think that occurred at 2018 or 2019, one of those iterations there. This is ideal for a developer because you can do things like have different triggering events to launch your FME workspace, be that an email message or watching an FTP site or Dropbox or a file share or putting something on the Windows or putting something on a scheduler. Automations have been great. And for the user, it's just black box. The user doesn't see any of this complexity. All they do is they get an email or a thumb drive in the mail or something with a bunch of AutoCAD drawings on it. All they do is drop those AutoCAD drawings within a folder, wait a few minutes, and check the output folders. They don't have to open up FME and run a workspace or anything like that. All they're doing is file management. They drop drawings in one folder, they wait a few minutes, and they see the output results in other folders, and then they can just continue their work. And this lends itself really well to how the data is delivered, it being bursty in nature, kind of that feast or famine where you don't see any data for a couple months, and all of a sudden you're swimming in data, and they can manage it accordingly. Also, it's taken it's made this, it's true standardization. These CAD techs that used to be manually converting each and every drawing to specification are now free to use their talents for more challenging things. They're not doing this drudgerous work day in and day out. They're free to do other things. And also this has accelerated how quickly they can do this work. They used to spend months and months out of the year standardizing drawings. Now they're spending minutes and hours doing it. So it's been a real time saver for this organization. Thinking about IMAGIN membership and knowing that a lot of you work in local government and utilities and other organizations that use that receive AutoCAD drawings from constituents or clients or companies doing work in your area. I think FME could be a great tool for you guys to use to standard AutoCAD drawings, and even to automate it, possibly within FME Server or possibly just using FME Desktop. So that's my presentation. I didn't really fill up the whole hour, but if you guys have any questions or comments, I'd love to hear them.
Yeah, Brooks, we have a couple questions that have come in. One is from James Bennett, which is, it must be referencing a previous slide, but he asked that it looks like there's no polyline work for the interior wall space. So that might have been referenced from earlier.
No polyline data.
Maybe this one.
Everything's coming out as polylines within here.
Okay.
It's kind of hard to see in this slide here is actually around the edge there's two lines, one's cyan and one's blue, and the cyan line represents the true outline of the building, the exterior building footprint, and then the darker blue represents the inside of that wall. I think it's kind of being obscured or maybe by the other stuff you see along there, but yeah, everything should be coming in that way, and it should be polylines. So I hope that answers this question.
And then another question that came in was, with one DWG having multiple floors, what logic is used to separate them into different drawings?
Yeah. That took a while to figure out. But what GSA does is they actually use viewports in AutoCAD, which is a feature where you can essentially put a window around each floor. And that's just part of GSA spec. So we look at each viewport to separate those out.
Cool. It looks like another one that came in is could this same kind of workflow on a smaller scale be produced with just FME desktop, or is FME server required?
No. In fact, you would not need that. You could run this all just through FME desktop, but you'd be running, it wouldn't be quite as easy for the end user. What you could do is you could have FME desktop looking at that folder and inventorying it and running it. But it would be up to you to kind of automate that, whether you want to start up FME desktop and run it, or just have it linked to something simple like the Windows scheduler. You know, a lot of people use FME desktop and then automate things using Windows scheduler. So you could dump data into a folder, and then if FME desktop was linked to a scheduler, just every 20 minutes or something, it checks and runs it. FME server just gives you that ease of automation of essentially it takes FME and operator knowledge of this completely out of the picture. It just makes it true black box for the end user. But you could run it interactively, or even could run it on a group of files using FME desktop. Good question.
Yeah, and I just have a question too, just from some of the demos I've seen of FME server. I know a lot of times they show, people dropping files on a web browser, and that's kind of what the trigger is for FME server.
Mm-hmm.
In this case, though, it sounds like, they're just placing files in a, folder, and that is the trigger then?
Exactly. So in FME server, these are called what they call automations. And automation is essentially something that's going to be used to automatically initiate an FME workspace. And that could be it could be a schedule, it could be a time-based thing. So run this every 5 minutes, or run this every day at 2 a.m., or run this every third Thursday of the month, or something like that. But an automation could also be watching something like a folder, Dropbox, an FTP site. It could be waiting for an email to initiate it. There's a whole bunch of different types of automations that they have built. The one we're using specifically here is what's called a directory watch, where just basically use this little widget right here and point it at a file, which in this case is a folder share, and it just watches that, and that's how things are initiated. So as soon as FME server sees a new file within there, it's checking every 30 seconds or so. As soon as it sees something in there, it initiates the corresponding FME workspace.
Yeah, very cool. Got a couple more questions. One is, for the comparison between drawings, is some sort of ID used to compare a specific room?
That's right. So every room has what they call a space ID, which you can think of just as a room number. It's hierarchical, so it's kind of the building number plus the room number. So you're in building number 1, room 233. The space ID would be 1233. So what they're doing here is essentially just a comparison. You can think of this just kind of as a join within a database. So you're getting an inventory of every space and the area of that space. And then you're joining it to another table, which is derived from the previous year's AutoCAD drawing that has similar information. And you're just joining by that space ID and comparing old area to new area. And I forget what the threshold is, but they made a decision that if it's like more than 2 square feet, the difference, then it's judged to be a change. There was some number, I don't remember if it was 1/10 of a square foot or 2 square feet or something in that neighborhood, that if those measurements are different, it's judged to be a change.
And then another question is, do you get into dealing with the coordinate systems the CAD drawings are in? And I guess it's a multi-part question. Is that part of the QC process? And I guess I'll stop there first, and then there's another one.
Yeah. So as far as like a spatial coordinate system like state plane or UTM, no, this is all a local coordinate system because these are buildings that aren't georeferenced. However, I do have to deal with coordinate space a little bit because part of the client specification was they want all of these drawings in positive X and Y coordinate space, and sometimes they'd come from GSA just with an arbitrary origin, and they'd be part in negative X and or negative Y space. So they wanted everything moved into positive coordinate space, but no, there's no spatial reference system like state plane or UTM. This is all just a local coordinate system.
Okay, and this might be more in general, but do users ever view their CAD data in a GIS environment where projections would potentially need to be converted?
Yes, I am actually doing a separate project out in California doing something like that right now, where sometimes they get CAD drawings that are in some sort of coordinate system, California state plane or otherwise, and it needs to be brought into that city's standard, and before it's brought into their GIS. And it gets interesting because sometimes when you get an AutoCAD drawing, there's no information about the coordinate system, so it just has to be assumed. So that can be kind of tricky.
And I think that looks like all the questions at this point. Yeah, very cool, Brooks. I appreciate you sharing. I can only imagine working with such a large client like that. But it sounds like they were able to, like you said, the end user didn't really have an impact, because that would be my first question is, before you mention that, is that, how much was the end user that had these drawings, how much were they impacted by this, implementation?
Yeah, I mean, they're very happy. I don't want to speak for them, but I've taken a lot of the drudgery out of their lives at work, and they're much more productive. Probably the most flattering thing I got from them out of this project is they gave us a reference to GSA, and we actually have a meeting with them next week to show them this project, because they might be interested in using our services as well. So, there's nothing like a referral to speak to client satisfaction.
All right, great. Well, I'm going to go ahead and we'll wrap up the webinar. If anyone has a question, feel free to enter it, and I'm going to go ahead and share my screen again here.
Yeah, and everyone, thanks for taking your time. I know you're all busy, and I really appreciate you guys spending an hour with me and hearing me out here.
Yeah, yes, very much appreciated, Brooks. Let's go ahead. So again, just wanted to thank our webinar series sponsors, Fishbeck, Giffords Webster, and also BSNA, which is actually hot off the press. They had just added as a sponsor, so I wanted to give them a shout out. And then just a reminder, for for the upcoming webinars, we have one next week on February 18th, which is Brownfields to Brightfields, Recycling Land to Productive Use. And that is by Ryan McNeil with the State Land Bank Authority. And then 2 weeks after that, on March 4th, we'll be looking at Pete Schneider's presentation on geodatabase replication. So again, thanks, Brooks. Appreciate the time. Thanks everyone for joining. And we'll be getting this recording out for future use. And hope everyone has a great rest of the week.